Yeah, so very happy to have Alexander Mädche here today. He's joining us from KIT, so Karlsruhe Institute of Technology. We've known each other for quite a few years now. And Alexander comes from a business background, business IT background, but has over the last 10, 8, 7 years done more and more also HCI work. And today he's talking about something that I think we're all very familiar with, and that is remote meetings. So very much looking forward to it. And thanks for being here.
Thanks, Mark, for the invitation. Thanks for being here. I will try to introduce you in some of our recent research that we have been doing the last 5 years on remote meetings. This is research done at the Human-Centered Systems Lab that I'm heading at Karlsruhe Institute of Technology. It's part of a graduate school called KD2 School that I will introduce you later. So why should we research remote meetings? I think since Corona, we have seen that the number and time spent in remote meetings is growing rapidly. And this is not because of just we have to. There's obvious reasons that time savings, reduced travel costs, and emissions are an obvious benefit of remote meetings. At the same time, we all experienced, I assume, negative impacts of remote meetings in terms of productivity, but also well-being. There was this term of video meeting fatigue that was promoted a lot in the last 2 or 3 years. So current technology comes with limitations. And the question is, how should technology be designed so that we increase performance and well-being of employees if we use video meetings or remote meetings in business, but also in private life. We consume and use this technology. So the key question is, what can we do? Now, we started, as I said, 5 years ago. And what we actually did is we did a first state-of-the-art review looking into how do video meeting systems impact users from a psychological point of view. We developed this so-called morphological box where we looked into existing research on video meeting systems and the impact on humans along dimensions of context, task, technology, and the psychological user state, as well as outcomes. This was published in the International Journal of Human-Computer Studies recently. This morphological box is also online available so that you can also interact with this literature review. We identified at that point in time 78 papers, and obviously there's a rapid growth in the last 10 years as this technology got more adopted. What we found is that there's a lot going on empirically with survey data. So people survey people how they consume or perceive video meetings. A lot is done on diets, so kind of very simplistic view of a remote meeting, because usually we have more than 2 people in a meeting, and people look at basic features, how humans perceive these features. In general, and this is also what we write in this paper, is that there is actually a lack of deep understanding of the users in terms of what really do video meetings do with us, how does specific functionality impact our life, how does it impact performance, but also well-being of users. And that is exactly what we started looking into in more detail. That brought us actually to the biosignals topic. And that is research that is joint work with Tanja Schulz from University of Bremen, where we looked into how can we better understand humans by capturing more real-time data through sensor technology. Because obviously, when you're in a remote meeting, you anyhow are in a controlled setting where you have your camera on, where you may also connect sensors to yourself. So you could share and use this data for A, a deeper understanding, and B, maybe even adaptation, as I will discuss in a second. So this taxonomy that we developed tries to map different types of human activities. As you see here, all this happens during a remote meeting. So there is gestures, there is eye gaze, there's hopefully some brain activity happening in the remote meeting, but also maybe hopefully heart activity. So the key point here is that with different sensors, that use different technologies, we can capture different so-called biosignals. We define biosignals as autonomous signals produced by living organisms measured in physical quantities using sensors. So for example, we can capture eye gaze through an infrared camera that is then translated into an optical biosignal that we measure, for example, through fixation or saccades that we then can compute within the remote meeting setting in a video meeting system, and we may use this for adaptation. So the idea is now, how can we use these biosignals to better understand what's going on in remote meetings? To do so, we conceptualize biosignal-adaptive systems following a biocybernetic loop approach. This is research which has some history in physiological computing, for example. In 2010, Faircloth published nice work here. The idea is, I think, very obvious. We have humans that attend a remote meeting. We capture biosignals. We record these signals in real time. We start processing and classifying these signals. We can do multimodal processing. For example, we can capture gaze activity and heart activity. And on this basis, we can try to predict specific user states that users are in when they're attending a remote meeting. If we know the states, which is a challenge, it's not trivial to predict user states, as you most likely know, we can subsequently adapt the remote meeting. And that's again a challenge because adaptation design is manifold. It's a huge design space in terms of implicit or explicit adaptation. Who is driving the adaptation, the user or the system? Or what exactly do we adapt, the content, the functionality, or the interface itself? The idea of this biosignal adaptive system is a general one. And what we do in the graduate school is we apply it for video meeting systems to improve remote meetings. And that's the graduate school in a nutshell. So it's an interdisciplinary school consisting of 12 PRs from 3 disciplines, KIT University of Bremen, psychology, management, economics, and computer science, around 30 students, PhD students and postdocs that research biosignal adaptive systems. A subset of these people does research on remote meetings. And I will share a little bit what we are doing there in the following. So keep that in mind. The idea of this whole graduate school is that we have humans that send biosignals. The information technology processes these biosignals. It adapts and then goes back to the human by sending adaptation signals. So the human adapts itself. And we do this in economic decision contexts that also send what we call context signals, both to the technology, but also to humans themselves. So for example, if you're in a specific setting of a meeting, the decision context influences the behavior of the humans, and it may also influence the biosignals before it comes to behavior. This is the setting, and we do that in a kind of unique facility. And if you're in Karlsruhe, I invite you to visit us. We run this so-called KD2 lab, which is a unique experimental research infrastructure with 40 cabins. You see them here, where we can do controlled lab experiments using state-of-the-art biosignal measurement technology. We also run an immersive space where we do VR experiments with biosignals. So the context of this lab is that we use the KD2 school as the instrument, large-scale experiments where we have 2,000 students in a panel that we can incentivize to participate in experiments. This gives us the opportunity to run also large-scale remote meeting experiences in a physical space. It's a little bit crazy. People come to the room and then attend a remote meeting without knowing and seeing, without knowing each other at least. They may see themselves through the camera. So that's the context that we are operating in. And I brought 2 studies with me that I will share with you now, and a little bit of an outlook where we are heading to with all this, why we are doing this. Now, the first study that I wanted to share with you quickly is a paper that was presented just recently in Costa Rica. I went to Costa Rica. I did rain 5 days at CCW. And the paper is called Mirror, Mirror in the Call. The ambivalent nature of the self-view in video meeting systems with self-reported and eye-tracking data. So it's subjective data that we collect through surveys and biosignal data that we record and collect through, in this case, eye trackers. This work is joint work with Julia Seitz and Ivo Benke. Now, what is the topic? And the topic is an interesting phenomenon that also was a lot in press, actually. And we just talked about that. It was even a Nature paper was published on this, because it's highly discussed if this self-view, which is a very unnatural thing, because in a normal meeting, you wouldn't put a mirror on the table to look at yourself to see how you look like. But in a video meeting, you do so. So we are doing something that doesn't exist in real world. We bring in a feature that should help people to be better in a video meeting. But the key question is, do people get better thanks to the self-view? There is evidence, and there was discussion on negative impacts in terms of fatigue. And there is also evidence in parallel that beside distraction, it can also support you in getting control, because the more you know how you look like, the more you feel confident in being in this virtual environment. Overall, and there is clear evidence in the literature, there's a lack of a deeper understanding on what exactly is happening if users attend meetings using the self-view or not. And that was exactly our research question that we tackled. So how does the self-view actually really impact control and cognitive load? What is the visual behavior of users? So do they look at this self-view, yes or no? Do they share similar patterns, or is there different subgroups of users that eventually do use the self-view very differently? And then obviously, how does that impact the control and load? So what we did, and this is a typical setting, how we do these studies in Karlsruhe, we did a lab setting. We composed 19 teams of 3 participants with overall 57 participants from this so-called KD2 lab panel, where we invite students and they come to the lab, they get an incentive, participate in the study, and then go back studying. So they earn money with this. So we have a kind of low mean age, not surprisingly, as this is a lot of bachelor students. In these cabins, we capture optical biosignals, and we let people fill out surveys, in particular NASA TLX for the cognitive load and control, for the perceived control, as well as quite some control variables. We have 2 treatments, no self-view. This is just we deactivate the self-view at all. You don't see it. And you have a self-view. These are the 2 variants that we let people engage in a video meeting. Now, what is the task? The experimental procedure is there is an onboarding, calibration of eye trackers, and then we have 3 rounds that these teams play. It's not a kind of game. It's a task that you may have heard of, Lost at Sea, Lost in Desert, Survival on the Moon, a task where you need to pick a set of items as a group to agree on. When you would go to the moon, what would you take with you? And the nice thing with this task is that there are some benchmarks. So it's a decision task that they have to work on and agree on. It's also demanding because people may disagree what you should take to the moon or the desert or at sea. And this was our setting. We didn't tell them that we do this kind of self-view study. We just let them in the meeting. Now, what was the results? We first of all observed that indeed, without the self-view, there's lower cognitive load. So all this discussion in press is true. The self-view is having negative impact in terms of our load that it produces. At the same time, there are individuals that suffer from control loss. That means without the self-view, they reported lower control levels. What we also learned from the data is that people are very different. Some people tend to exploit the self-view a lot, others don't. So it's a little bit of a tricky thing what we do, because in general, one could say then just kill the self-view, but that would again be not the solution to the problem. Now, we look deeper into the data, and we looked into the visual behavior, how it evolves over time in these meetings. And we learned that there's two major patterns. There is the continuous viewing pattern and the non-continuous viewing pattern. Continuous viewing means that from time to time you look at yourself to check if you're still looking okay. The non-continuous viewing is the behavior where you look at the beginning of the meeting, and what you see here at some, here it was, at some 6 or 7 minutes, you again look at the self-view. So visual or behavior patterns are very different, but there's two dominant patterns of people. We also interviewed the people, by the way, and we got quite some evidence that there is different self-viewers at the end of the day. Someone said here, I look from time to time, and this was exactly a kind of continuous viewer, and others said, I look especially in the beginning of the meeting at my self-view. Now, we did also look at eye tracking data, and obviously you see also that people especially differ here in the behavior. There is the self-viewer pattern where people really focus on themselves more than on the meeting, which is a problem. And there's people that really focus fully on the meeting content and the colleagues. Yes. Sorry? We use Tobii 4C eye trackers. No. That's a desktop eye tracker, exactly. And that is a kind of solid device. We also did fix them in the cabins in terms of not having dynamic wheelchairs. So it was really like a stable controlling with also calibration for sure. Now, what we thought of, if there's different users or different behavioral patterns, why not doing a clustering? And we clustered the visual patterns, and we indeed learned that there's 3 clusters in our data. We had users that really benefit from the self-view. They have a low cognitive load, they have high control, they interact not that often with the self-view. So these are the people that really know how to deal with the self-view feature, so to say. We have users that are cognitively challenged. They have a high load, medium control. They interact more than the benefiting, but this creates load. And then we have the control-losing users, as we call them, because they complained, and also we see that they report very low control. And if you compare the box plots here, you obviously see differences when it comes to load and perceived control and fixation patterns. So these 3 clusters were interesting for us because that were actually, again, an argument we would need to adapt the self-view to the user type or the behavior of the user itself. Now, what do we learn from this study? In the CCW paper, we mainly report these results. And obviously, we moved on into how can we adapt this. The key message of this study was, okay, removing the self-view is not a solution because we would lead having people to lose control. Some may suffer from the self-view because it produces load. So we need to do something here. And this is exactly where gaze adaptive self-view in video meetings comes into play. And that's again the adaptive systems cycle. So we have people being in the meeting. We record the gaze with the eye tracker in real time. We process this data. We analyze the gaze pattern. We, for example, identify the cluster type. So to which cluster does this user belong to? And on this basis, we adapt the system functionality by deactivating the self-view. We also did a lot of interviewing what people would prefer. And obviously, people wouldn't prefer that it's automatically deactivated because that would again lead to control loss. We would suggest deactivating the self-view because it's time to focus on the meeting. And then you could again stay in the meeting without spending too much time with the self-view. So it would be there at the beginning, and then it would disappear at some point in time when it's time to refocus, so to say. So that's one way of adapting to the gaze patterns. And could be interesting to implement that as part of commercial video meeting systems. It would require an eye tracker, but technology is emerging quickly, so it's not that unrealistic that this is technically feasible very soon. Now, the second study is something that is work in progress, and again wanted to share with that because it's a phenomenon that we are most likely all can connect to. It's multitasking. So who of you ever did that? I assume no one, being in a remote meeting and in parallel doing something else, a secondary task, reading emails, writing a paper, doing whatever kind of things because the meeting is boring or you have other priorities. It's a conflict. And what we asked ourselves is, what is the impact of multitasking on flow, cognitive load, and meeting outcomes? Can we measure that subjectively again, but also can we measure it through biosignals? Because if we would recognize possible negative impacts of multitasking, we could suggest people to stop multitasking or interrupt the meeting or do many things to prevent creating negative outcomes on the human side. Now, a very typical setting, multitasking is defined in our context as the simultaneous performance of two or more independent tasks. We switch between these tasks. Switching behavior is creating effort. That's nothing new. But indeed, if we look into literature, there is not much on multitasking in a team setting up, and there's a team setup, sorry, and there's close to zero to multitasking in remote meetings. So we asked ourselves, as this is a widespread behavior, and in individual work, it's known to negatively impact cognition and performance. What is the impact of multitasking in remote meetings? And this is an interesting question because it doesn't only affect me, it may also affect my peers, because it's not that much social behavior if you ignore the meeting and just do your secondary task. So a question obviously is, could biosignals help to discover something, what is going on here, and then in a second step, adapt again? So first question, again, understanding. How is multitasking impacting load, flow, and meeting outcomes? I will talk in a second about which type of meeting outcomes we look at. And then second question, do biosignals tell us something about these states? Now, again, a setting not unusual for us. We took 72 participants. This experiment was much more complicated because we had to get people into a multitasking mode, which is not that easy in a controlled environment. So we did the following. We did two treatments. One was, again, this survival on the moon task in a typical meeting setup with 4 participants. This time, the self-view was on, so people could see each other. And 2 participants in the meeting got a secondary task, which was an invoice matching task that we tried out in a study before. This invoice matching task is cognitively demanding because you need to match invoices to costs, and you need to calculate a little bit what is going on here to get these tasks done. We incentivized people for attending this meeting or attending the experiment, the meeting, and you could earn additionally €8 if you matched your invoices correctly. So there was an incentive to do multitasking, and people did multitasking. And in parallel, they also attended the meeting. So, and the others didn't know that because it was on one screen, so you could do both things in parallel. Now, this setting, as I said, was a little bit complicated. We had 2 rounds. This was one survival on the moon, and I think one on the desert task. We had a moderator, 2 non-multitaskers, and 2 multitaskers that then engaged into the task. And we collected a lot of data, much more data that we could analyze, by the way. Indeed, we collected ECG data, heart activity, we did an EEG, and we did eye tracking. So it was a kind of massive setting. Here you see a photo of Julia that is in the cabin being connected. We used an EEG, a lightweight one, for the ear. and we used Polar H10 to capture the ECG, and we used again the Tobii eye tracker for eye tracking. We collected self-reported data, cognitive load again, and flow, and two meeting outcomes. Process loss is a performance measure in terms of how you perceive how your performance in the meeting was, and satisfaction is how you feel satisfied with the meeting. And this is work in progress, so I haven't all results already with me, but some of the results I can share with you. So about the self-reported data, first of all. So at the end of each round, people had to assess their flow states and their cognitive load. And what you obviously see here is in the multitasking condition, people had a much higher load, which is not surprising. And they had also a much lower flow state in terms of compared to the non-multitasking treatment. So people were challenged cognitively, and they didn't fully immerse in the task, neither in the team task nor in the invoice matching task. People in the multitasking condition are also not satisfied with the outcome of the meeting. So it doesn't make you happy if you multitask. And they also perceive they lost in regarding the meeting outcomes. This is all significant. So there's clear evidence from the self-reported data that there are detrimental effects of multitasking in this experimental setting. Now, we are still looking into the biosignal data. And as I said, we did research in advance on flow and heart activity. There's quite some research arguing that that heart rate and heart rate variability show clear evidence in terms of a balanced parasympathetic and sympathetic nervous system state. That means in a flow state, when you fully engage your work, you find a good match between your sympathetic and parasympathetic nervous system. And this is exactly what happens when you do multitasking. You go out of the flow state because you go into this environment where you diverge between your parasympathetic and sympathetic environment. Indeed, you get overload. That means this is also what we see in your heart activities that we measure with the ECG signal, and this is also significantly different for the time domain features. This is interesting, as we could actually see if someone in a meeting is really engaging fully in multitasking. We could, for example, suggest a break or suggest whatever, as we want to prevent multitasking. So these directions actually are confirmed with existing literature. This is nothing new. It's just interesting to see that this also appears in a remote meeting setup. So multitasking has a detrimental effect on load and flow and subsequent meeting outcomes. At the same time, people are challenged in doing their work. So it's not like that you do multitasking because it's so much fun. Most likely you have a lot to do, and then it's a matter of time. Now, how about designing a system that leverages biosignals to recognize this trade-off between load and flow? And what we indeed suggest, and we are doing that exactly now, to build what we call biosignal-adaptive assistance for task management, where you attend your meeting, and obviously you want to get your work done. So to some degree, you may need to do multitasking. We record the biosignals. We try to automatically recognize the user states, and on that basis, bring in an assistant that, for example, suggests micro breaks. We did a study on load adaptive meetings where we monitor the load of all participants and then suggest a micro break so that people can either relax or do some work. Maybe you know that in physical meetings, people also do breaks to have a phone call or whatever. And this is exactly the same. It's also to a kind of controlled multitasking environment. And obviously with AI, you may also want to delegate some tasks instead of doing them by yourself. The AI could multitask for you, and this is where these assistants come into play. If these assistants know about your state, they can also proactively propose that they can take over or suggest a break. Now, this is again this kind of circle that we push here. And the idea, and this is also what I wanted to bring and share with you at the end of my talk, is this is a complex phenomenon what we're doing here. Remote meetings, research in remote meetings is difficult because in general, team research is more difficult than individual level research. Doing this with biosignals and sensors is even harder. So we try to accumulate knowledge. What does that mean? I shared a little bit what we are doing on biosignal-adaptive systems. I shared quickly the biosignal taxonomy. I didn't talk a lot about user state recognition. This is a field for itself, a fastly, quickly evolving field. And what I didn't talk about, I'm still dreaming of that, is the adaptation design taxonomy in terms of how can we structure the design space for adaptations. There is some research, but it's, from my point of view, not well elaborated. So in order to accumulate knowledge, we need to clearly define which biosignals we are talking about, which sensor technology we use, which activities we monitor. We need to be clear about which states we want to recognize. And then we need to be very clear what we can and what we want to adapt. This is in general important, and then we can contextualize that into remote meetings where we have either existing features like the self-view or new adaptive video meeting system features. That's the technology side. Then again, it's about the states we want to understand and improve. And finally, it's about the outcomes, be it performance or well-being, or ideally both, because that may be a trade-off in remote meetings. I didn't have enough time today to talk about all this. I shared a little bit of the taxonomy. We did work on cognitive state detection with eye tracking. We did work on flow recognition through experimental lab studies published in Transactions on Affective Computing. And we did stuff like the self-view feature. But there's even more, and this is exactly now a little bit too broad, but this gives you a feeling how these different graduates in this graduate school try to contribute to this kind of accumulated knowledge goal. So we have work on joint attention support for remote meetings. We have work on mutual gaze, where we simulate shared gaze through eye tracking. We have work on silence adaptive interventions. This is where we process an audio signal and recognize moments of silence and adapt for silence. And we did work on emotion management, emotional competence in video meetings, which is a different state, but may reuse different mechanisms like, for example, state recognition methods, but also adaptation logic, which can be the same. And this is what I mean with accumulation. That we need to agree on the key terminology so that people can build on each other and learn from each other and aggregate the knowledge for this interesting field. So that leads me to the summary. And I would argue technology for remote meetings today is limited. It has negative impacts, and obviously you can argue just don't do remote meetings, but this is not reality. They are here to stay. They will not go if we like them or not. So the key question is, how can we improve the technology? I would argue that this biosignal-adaptive systems concept, I call it, is a promising enabler to improve remote meetings. And there's more to come, obviously, because the combination of immersive technologies, biosignals, and AI in terms of highly personalized systems is obviously an opportunity to improve these technologies much more. Still, I would argue accumulating the knowledge for this technology is important, especially, for example, if we now go to an immersive remote meeting setting, or if we use other forms of adaptations, be it hyper-personalized assistants that do whatever with us. It's still interesting to understand how people react and how we design these features under consideration of the biosignal processing stream. So be these meetings with avatars or be these meetings with holograms in an immersive environment, I still think that this is an interesting stream of research, and I'm pretty convinced that biosignals will be part of our daily life, and we should try to make the best out of it. So that was it from my side. Here's just a short impression of the team. This is the Human-Centered Systems Lab. I shared today research on biosignal-adaptive systems. We do work in conversational assistance, personalized enterprise systems, and human-computer co-creation. So if you're interested in that, just look up the webpage of the lab or the graduate school, which is the so-called KD2 school. Thanks for attending, and I'm now available for any kind of questions you want to ask me. Thanks.
Other questions?
Thanks very much. There's certainly a lot of work going on there. You mentioned lots of the different biosignals that you can measure. And I wondered, through all of these different PhD students and your reflection on which ones are perhaps the most useful in terms of helping us understand what's going on, and for you, because they take a lot of work to analyze, compared to, say, self-reporting and traditional performance measures like time. So I wondered, which ones of those do you think that, is it eye tracking? Is it the GSR or the EEG? Or do you think you need to have all of them?
I'm strongly voting for stable technologies, so we are not developing new sensors. And we made a lot of good experiences with eye tracking, as this provides a very solid signal. If you calibrate this thing, it is really working well. We made, again, a very good experience with ECG, as the devices, be it ECG or PPG, as an optical signal. This is a robust signal, and there's commercial products that you can buy out of the box. So if you want to do or bring this stuff into the field, I would vote for these biosignals. If you want to do foundational research, we also have actually in the KD2 school an fMRI in Bremen, and we even have 2 fMRIs connected in Oldenburg and Bremen, where we can do analysis of remote meetings and real brain activity during a remote meeting. Then it's foundational research, but this is the question, what you want to achieve with the signal. I would be careful arguing that EEG is not yet ready. Maybe it's not yet, because if you have movement in your face, especially if you speak, then the signal is not usable. But that may change in 2, 3, 4, 5 years, I don't know. But I would vote for heart activity, gaze activity, and that fits also very nicely to video meetings, beside obviously the audio signal itself. In the silence adaptive system study, we just looked into the audio signal. When it's silent, it's silent. It's not that easy to recognize if the silent is good or bad, but this is, again, a very important signal. So that's okay. And we also observed the smartwatches evolving very, very quickly. So it's getting really convenient to wear such a device and use this data if you want for your meeting.
Thank you. For the bioadaptive side of the research, how are you identifying what part of the video call to adapt? Because I imagine in your first study, there were 3 kind of cohorts based off how they were affected, based off seeing themselves. I can imagine if you have a kind of adaptation based off the image itself, it will be positive for some, not positive for others. How would you customize that, or that's still too early to say?
This is exactly the design challenge. I call this the adaptation design challenge, because it's super hard to come up with a good design. So this is where we do very traditional participatory design. We invite people, we do co-design. We do a lot of things to explore an appropriate design, and then we test it with the users. For the self-view, it was relatively easy because there was on or off, but it's not, because the question is, how do you inform a user if you remove the self-view? And you can't do that automatically. People wouldn't accept that. So this is where you need to do a kind of mixed initiative design, where you suggest, and then people can confirm. But that's actually what I say, a challenge. And this is also not well conceptualized because it's not super straightforward to decide what exactly do you adapt and when. When you have this timing aspect, you have this type of adaptation. So that is ongoing research. And I would, for those that search a topic, do an adaptation, design, classification, taxonomy. There's some work, but I would say nothing that is well accepted. I mean, in HCI, there's this adaptable and adaptive terminology, but that's it. What exactly to design, to adapt is a tricky thing. But in a very important one, because the best, biosignal and the best state recognition doesn't help if you don't deliver the right, let's say, intervention for the user. You can even damage, because if you provide the wrong intervention in terms of adaptation, it may backfire. And that's, yeah, exactly. It could even create more load, and then you rather do nothing. And that is definitely what we want to prevent. But again, you need experimental studies, and this is also why it's a continuous loop. Whenever you do an adaptation, you need to see how the users react, and you can then use again the biosignal chain to see if, for example, the adaptation even increases the load. Then you should take it away, obviously. So that is why it's a kind of biocybernetic system.
Look at themselves.
Stress.
Oh, they're stressed now. Turn it off.
Exactly.
Exactly.
Yeah. So it's not a trivial thing to design such systems end to end, because throughout this whole process, capturing the biosignal, recognizing a state, and then delivering the adaptation is complex. And that is why I would argue this accumulation of knowledge is so important. And this is also why I push these guys to build up on each other's work, which is sometimes not the thing that people want to do, but in this case, it's really necessary to reuse some of the stuff.
Thank you very much. I was wondering about the second proposed solution with the AI assistant potentially prompting micro breaks for people set based on cognitive load or sort of other biomarkers. I was wondering, how would you propose balancing the needs of different users in that interaction? Since if one person might be experiencing a high load, another person might be in the flow, and balancing that with the content of the conversation as well, because there might be sort of natural breaks in the task versus not.
Yeah, we had endless discussions about that, and there's obviously not a final solution for that right now. But indeed, this is a typical example of how difficult the adaptation design is. You may be able to measure the load of the different people in the meeting, but how do you now decide what is the right adaptation in terms of a threshold, or at least 2 people should have higher load? There is no answer to that right now, and it would be very hard to systematically test that. We had qualitative investigations asking people about their preferences, but you can imagine everyone has a different preference, and it's also delicate, because you definitely don't want to share your load with others in the meeting and argue this is the guy because we have a micro break now. So that's an open question.
Yeah, so there's a sort of a privacy question there as well, right? Because you don't want to, for it to flash on everyone's screen like, oh, Mary is having high cognitive load.
No. You would definitely need to do that much more delicate or kind of seamless. And one could also argue, okay, if you have a good schedule and you organize your meeting well, you know that there's these methods after 25 minutes do a break. That would be a kind of static intervention. But I would argue again, people are very different, so it may be worth doing some level of adaptation in defined time windows, for example.
So yeah, thanks for your presentation. I have multiple questions, but I'll restrict myself to 2. In the first study, you said you found 3, let's call them archetypes of people through some clustering. How did you do the clustering?
Yeah, we do the very traditional hierarchical clustering first, and then a k-means clustering, elbow criteria, and 3 clusters seem for the given data the best number of clusters with k-means. And on that basis, we developed the archetypes and also did a little bit of storytelling by naming these archetypes with these three groups. Okay. But obviously, if you would have a larger data set, that may also be that there are small archetypes. I wouldn't argue that these three are completely reality. The data was collected in an artificial lab environment. So be careful, but I would still argue there is definitely different behavior. And if you look into video meetings, I do that because obviously I deal with this topic. There's people that seem to be really taking care more of themselves than of the meeting. So people looking at their hair and trying to be beautiful. Men are often looking at their hair. Just observe that. And you see that if you think about what is this person now doing, obviously he, or most likely he, is looking on the self-view. So look at that. That's really interesting to predict how much they self-view in a meeting.
And then another question, which is more looking further in the future. So you have this overview where you have all these different kinds of questions, like and one of that is user state detection. Obviously, that's an important one. I did something a few years back where we also said user state in cars, and then the question that we got from reviewers is, why do you actually even want to predict user state? Just predict the intention or the wish. What are your thoughts on this? Can we just can we predict wishes? Also, for example, offloading to AI. Predict what they actually want.
And this is a hot topic these days. Intention prediction.
Should we maybe just scrap
state? No. So, definitely not. I would definitely think, okay, it could be interesting to predict intentions, but in parallel, I would also like to know what the states are, because maybe sometimes people should be prevented to follow their intentions or at least alerted that this may be dangerous to follow this intention because you have a high load or whatever. I would not try to go to this kind of full automation thing in terms of I know what you want and then you just get it. But it's good to have people in the loop also arguing that at some point the system may step back and give the control to the user doing things manually. In aviation autopilots, we had that in human factors research. There is this adaptive automation thing, and you don't want to really let the human completely get back. That is why you need to know a little bit about the states of the human, and then you can subsequently trigger actions. So I would be careful to let's say, ignore the human and its state. The question that one could argue, do you really need a state, or would be a trait be good enough? This is what we get from time to time to reviewers. If you do a lot of fancy state recognition, real-time, super complex, would a trait prediction be good enough in terms of personality traits or whatever?
Interesting. Thanks.
Thank you for the talk. Kind of related to this, I was wondering, and maybe you mentioned it a bit throughout the talk, but overall, what is your impression of people's self-awareness of all of these of these states, and also awareness of the people you are talking to, what their kind of state is?
This is a very good question, and we did research on state awareness, especially regarding emotions, and we did smartwatch-based studies where people had to label their emotions, experience sampling based. And we learned a lot that just by labeling their emotions, they learned more about themselves because they asked themselves, in which emotion am I? So it increases the awareness of the state itself, or knowing or reflecting in which states you are. And actually, a lot of this stuff could be used for retrospective analysis. And one study was about emotional competence in remote meetings, where we let users, after the meeting, reflect about how emotions evolved over time. And then you could review the meeting, so to say. We could do the very same with cognitive load or flow. We did also a small flow app, as we called it, where you could look during the day and see at which states, at which point in times of the day you were in which state, and you could also correct that by themselves by self-labeling. I believe this is super interesting because people have hard times to assess really their states in real time. And this is also where survey-based methods come to their limitations, because whenever you ask someone to fill out the flow survey, you're not in the flow anymore, for sure. If it's feasible to recognize that and then afterwards present that to users, could be very, very interesting. So there's people that flow is to some degree also a trait, that really have the trait of getting into flow. And if you learn how to get into flow, obviously that helps you to perform better. There's a lot of conditions to get into flow, but I would argue awareness is a big topic for itself. And when these sports apps do nothing else than giving you data about your physical activity, and this is cognitive activity. Max Wilson calls it cognitive activity monitoring, which is also a kind of way of getting into knowing more about yourself, which to some degree, by the way, is also dangerous because self-tracking may also have adverse effects. No? There is studies showing that the more you track yourself, you may change your behavior. For example, if you don't feel good, you don't do sports because that would record that you don't perform well. So you rather don't do sports at all. So this is a dangerous, delicate thing to throw technology on this problem. That is what we also have to understand. Maybe sometimes not to rely completely on technology. That's at least my opinion. Interesting topic.
Oh, and then the flip side, the partner who you're talking to, their awareness of your of your cognitive load, of your engagement was there.
We didn't do this kind of research in a kind of social setting, how people think they can assess the states of others. We didn't do that so far. But would be an interesting question, how easy it is when in emotions, there's a lot going on, how to assess with kind of emotional intelligence, others' emotions, with empathy and all these good things. But I'm not sure of studies that looked into to predict in a team setting how others load or flow or whatever cognitive state is. We didn't do that, but would be possible. You could actually retrospectively also analyze these data anonymously and then learn about your peers. And this may also be interesting for team leaders to understand what's going on throughout the meeting to improve the meeting culture or the meeting organization in general. So there's a lot to do.
Are there any other questions?
One more quick question. I think size. Yesterday, I was having a video conference with my two co-authors, and I looked far too big, so I immediately switched myself off. Whereas in the morning, I'd had a meeting, a management meeting. There were 25 of us, and I didn't see myself. I was just this little box down here, so I didn't. But it really just threw me to see such a big image of myself. So I wondered whether you'd looked into, you did 3 or 4, but if you've got 3.
We didn't look into large meetings because you know what? It's even harder to collect empirical data. If we would need, this would cost thousands of euros because you would need to invite many people in parallel attending a meeting. We do currently a study with crowd workers where we use Prolific and invite people in real time into video meetings. This could be a way to scale, but just pragmatically, we had to go for 3 or with the multitasking study with 5, which is already a challenge because if you invite the people to the lab, one doesn't show up, you have a big problem. It's the hell to do these experiments.
But you could go with changing the size. So, when you're on FaceTime on a phone, it's very different from looking on that big screen up there.
Absolutely.
And how does that impact?
Absolutely. It would be super interesting as a kind of adaptive intervention. And that's nothing else than an adaptation that you dynamically change the size of the self view. It wouldn't need to require to eliminate the self view at all, but rather making it bigger or smaller depending on the setting of the meeting and your state.
Cool. Thank you all for all these questions. Let's thank the speaker again. Alexander will be around for the next 2 hours approximately. So if anyone wants to have another chat, I'll be showing him around, showing him the basement lab, showing him some stuff that I do. If anyone wants to join, I'm very happy to do so. And yeah, thanks for coming. And it was a great talk.
Great to meet you. Thanks
Yeah,
very
it
much.
was a pleasure.
I've got to head off to the Canary Wharf now to talk.
Oh, okay.
Go to an event on
Okay.
AI and women. So
Oh, AI and women. That's a good topic.
we're giving out prizes. So
Okay.
I'm going to make my way over there now. But
It was
anyway,
a
nice
pleasure to meet you. Hope to see you again soon. Are you at Kai in Yokohama?
Yes.
I will be